Hi, and welcome to Matt's Workshop. This is part 5 of this series of my small workshop workbench build, so if you haven't already, please go watch the previous parts. Next is the locking handle core. It's made of a thick aluminum stock and it has two M8 mounting threads, and one of the extremity of this part is rounded. Again, I start by squaring up a piece of raw material and I bring it to its final size. Then I can position and drill out the minor diameter of those M8 threads. And I'm also using a reamer for this minor diameter because I'm going to be using a pin as a guide to cut the rounded shape at the end. But for one of the threaded holes, I can tap it right now. Then I can use the rotary table to cut the rounded shape at the end of the part. When this is finished, I can remove this part from the rotary table, and off camera I tapped the second M8 thread, and this completes this part. The next parts to make are the locking handle side plates. These plates get installed on both sides of the handle core that I just made. They are made with a 1/4 inch thick aluminum stock, and I start by squaring these stocks together in the milling vise. Then I bring both parts to final thickness and length. Here again, I can position and drill the necessary holes. One of the holes is going to be reamed to be able to do the same radius cutting operation as I did on the handle core. And the two remaining holes will be countersunk for M8 flathead screws. And I can go on the rotary table again to cut the radius on both side plates at the same time. And back in the milling vise, I start to cut an offset hole. This offset is what is going to create the cam action when the handle is turned. This will pull and push both braking pads to squeeze the aluminum extrusion of the fence rail in order to lock the soft fence in place. Another component that is necessary for this cam locking mechanism is the handle crosspin, which I'll be discussing next. I start on the mill because I want to make a flat on both sides of this cylindrical component. I'm using a square collet block to hold the part so I can easily rotate it and index it 90 degrees for every operations I need to do. I'll be machining both flats first and then I'll turn the part around to drill a cross hole. Then I go back on the lathe where I can face the part and finish the outside diameter across the length of the part. Then I can part off and I just turn the part around in the collet holder to finish the other side. The crosspin I just finished is going to rest against the adjustment knob I'm going to be making next. This part can be completely made on the lathe, and this is just a simple bushing with a M8 thread in the middle, and the external diameter is knurled to give it some grip. Next will be the handle guide bushing, which is also a very simple part with only 3 features. First, the external diameter is going to be machined to 22 millimeters. Then on one side I'm going to machine an M18 by 1.5 millimeter thread. And finally, the center of the part is going to be bored and reamed to 12 millimeters. Unfortunately, I made a stupid mistake here and I did not drill the hole deep enough before parting, so I now need to finish it from this side as well. And here I decided to go back on the mill to add some flats on this part in case I needed them to turn it around. It turned out to be a mistake. I should not have done this. It's unnecessary and it's actually better to have a larger flat surface there. So I should not have done that. But this is still going to work fine. Next is the pole rod, which is going to link all of these components together. This is a small shaft of 12 millimeters of outside diameter with a shoulder of 8 millimeter on one side and M8 threads on both ends. And you will see me here making it out of aluminum, but I decided to change that later on and make it out of steel. Now I need to make the mounting plate, which is the largest machine part so far. This part is made out of a 4-inch wide by 1/2 inch thick aluminum stuck bar. It was first cut on a bandsaw in the material store I bought it from, so I need to clean and square off both ends, and this is quite at the limit of what I can do with my mini mill. And off camera, I marked the position of the 3 roller bearings for which I need to drill holes now. Each hole is drilled and chambered for an M5 socket head screw, and then the center of each hole is enlarged to accommodate the adjustment of the eccentric bushing that I'll be using to fine-tune the position of the roller bearings. And then I can go back on the milling machine to make the slot in which the fence is going to be installed. And then I also have about 6 holes to drill, some of which will be countersunk. Next, I need to make the bearing support that I will be installing at the tip of this saw fence. This is just a small aluminum block that I start by squaring up. And then I need to machine out 2 slots to receive some socket head cap screws. And finally I need to drill and tap another small hole, and this is it for this part. And it's finally the time to assemble all of these machined components together. And this is probably the moment where everything is going to start to make a little bit more sense for you, so I let you enjoy this assembly. And here is the mechanism in place, and you can fully see how it works now. this is it for this video, and I wish for the next video to be the last one of this series. So it might take a little while to come out, but I hope to be able to show you every component finished and to have a walk around across the workbench. So stay tuned for next, and if you enjoyed this video, please like and subscribe. And thanks for watching!